Hello everyone, welcome back. So today we'll learn about trig functions of any angle. So you may have seen my previous video on finding the trig functions of acute angles. I want to expand those ideas to finding the trig function of any angle. Our goals will be to find coterminal angles of any angle, explain what that means. Also be able to find complementary and supplementary angles, and also be able to find the values of the trig functions for any angle. So first let's talk about the idea of coterminal angles. So on the right, or let's use them on the left, it says the coterminal angles, I should do coterminal angles first. I should take it back. Let's do complementary and supplementary first. Doesn't matter. Let's just have those in order here. So a complementary angle or complementary angles are angles that add to 90 degrees. And supplementary ones that add angles that add to 180 degrees. Let's take a look at a few examples of this. So complementary angles. And those are angles that add to 90 degrees. So like a very basic one. Let's just draw a right angle here. Okay. This is right angle. So how about we have, let's say we have this angle is 60 degrees, and this angle then is 30 degrees. Okay, so any angles that add, that's one example. Okay, so any angles that add together to 90 degrees are what are called complementary angles. Okay, so then if we have specific examples, like we say, we want to find the complementary angles of, and then, we have an example such as, 33 point, let me change that. So how about 28.7 degrees? Well, the way to do that then, of course, is simply to say equal to 90 degrees minus that 28.7, and just do that with your calculator. So 90 minus 28.7, and that's going to be 61.3 degrees. Okay, 61.3 degrees. So if we draw a picture of that, then like we did up there, if we have a right angle, and if this angle is 28.7 degrees, then this angle has to be 61.3 degrees. Those are complementary. Okay. Then supplementary angles, similar concept, supplementary angles add 180 degrees. So look at an example of that. Then actually just have a straight line. So it's called a straight angle. If you think about going from one side to the other, it's 180 degrees. Let's say we have here, let's say this is maybe, let me make this 45 degrees. Okay. Then this angle, if that's 45, this angle then turns to be 135 degrees. Okay. Those are supplementary because they add, you add these together, these add 180 degrees. So then if we want to find, let's agree with the supplementary angle of, let's just do a quick example. You can squeeze it in right here of, well, it's number one, of 101.8 degrees, and that's simply going to be 180 minus 101.8 degrees. Just do that with your calculator. 180 minus 101.8, and that's going to be equal to 78.2 degrees. So then if we draw a picture for that, so 1 this is 101.8 degrees, and this angle here is going to be 78.2 degrees, and both add to 180. Okay, so that's the idea of complementary and supplementary. So both a very simple concept, but can be fairly useful. Now let's talk about the idea of coterminal angles. let's look back at the left, what it says. Coterminal angles are angles that end in the same location. Okay, so what do I mean by that? Is we draw a set of axes, and this angle theta I'm going to draw could be anywhere. Let's make it the first quadrant. It could be anywhere. Say this is my angle theta. Okay. Now, if I go take another angle and maybe go, let's say, go around more than once. Okay. And let's call that theta number 1. Okay, theta 1. That's coterminal. Or if I go in the negative direction, for example, call it theta 2, then theta 1, and theta 2 are coterminal angles. Because they all end in the same location. What's important about that then is they all have the same values of the trig functions. Okay, sine, cosine, tangent, and their reciprocals, they all have the same values. So as long as you end in the same spot, you have the same values for trig functions. Okay, so now let's actually practice finding coterminal angles. So actually then to add, to find any coterminal angle, okay, you just add or subtract 360 degrees. So let's pick an angle, all right? So let's say I want to find coterminal, let's call this number 1, find coterminals, abbreviate that, angles, spell that right, of, now let's say 100, yeah, just 100 degrees, that's good, okay. Now, positive, okay, well, that would just do 100 plus, remember, 360 degrees all the way around. Remember, positive direction goes in, positive direction is counterclockwise, and a positive negative direction is clockwise. So positive would just be 100 degrees plus 360, be 460 degrees. Okay. Another one would be then just add another one. So then 460 plus 360, and go around again, and that would be, so 460 plus 360 would be 820 degrees. Okay, those are all coterminal angles. Those all end at the same place. I'm going to do negative coterminal angles and just take 100 degrees and subtract 360 from it. That's going to be negative 260 degrees. Okay, then if you want to find another negative coterminal angle, just do negative 260. Once again, minus another 360 from that. This says we're going, first time we're going around in negative direction, getting back to where 100 was. It's negative 260. This time, go around again. So we have negative 260, then minus 360. And that turns out to be negative 620 degrees. So those are coterminal angles. They all end the same place. And once again, the value of that is they'll have the same values of all the 6 trig functions. So you find the trig functions for any one of these, you find the trig functions for all the coterminal angles. Okay. Now, another important thing with coterminal angles is be able to find the least positive, or what's called the least positive coterminal angle of some angle. Okay, a lot of times that's really important to do. So let's see how that works. So let's take a look here. Let's say we want to find the least positive coterminal angle of, let's do a couple examples. One, let's do a positive, let's say 520 degrees. Okay. What I do then is it says, so you have a large positive angle, one that's bigger than 360. What you do then is just simply subtract, do 520, your angle, minus 360, okay, and see what that is. So 520 minus 360 is going to be 160. Okay, so that's the least positive coterminal angle. So we draw a little picture of that. 160 degrees would be saved right about here. Okay, so 560 is basically going around like that, and that is, or 520 degrees looks like that. Okay, so it's least positive coterminal angle. Once again, so you want an angle between 0 degrees and 360 degrees. That's what that means. And so its least positive coterminal angle is that 160 degrees. Those two end in the same place. Now, let's do a negative one. Let's say we do a negative, kind of a larger one, a negative, how about we do 1105, negative 1105 degrees. Now, to do this, if it's negative, a large negative angle, we want to add 360 degrees. And we have to keep doing that until we get to something that's between 0 and 360 degrees. So if we do this, that's going to be negative 1105 plus 360. Let's see what that is. And that's going to be negative 745 degrees. No, that's not between 0 and 360. It's also not positive. Okay, so when you do this again, so then next, then we'll do negative 745 plus 360 again. So add 360 to that. Okay. And that's going to be negative 385. Okay. Now, once again, we're going for something between 0 and 360 degrees, still not there. We're getting closer. Okay. Let's do the same thing again. So subtract, so do negative 385 minus or plus 360. And that's going to be a negative, so negative 25 degrees, still not quite where we want, but we're almost there. One more time. Okay. And then the last one, so negative 25 degrees, once again, plus 360. And that's going to be positive 335 degrees. Okay. So if we draw a picture of that, just the last one, 335 degrees is actually right over about here. This is actually 335 degrees. Okay. Now, all these are coterminal angles. Okay. They're all the same values, including this one. So you have 5 coterminal angles. And so base looks like we're going around probably 4 times or so, 3 or 4 times to get to that one. But that is the least positive coterminal angle of that. Okay, so that's the idea of, once again, first off, complementary and supplementary angles, and also coterminal angles. So that kind of sets us up. So now that we understand kind of angles, how these work, let's think about a few more things about angles in general. Okay, let's talk about the trig functions of any angle. All right, so we can think about the trig functions of some point in space. Ooh, sorry about that. The trig functions of any point in space so if we have some point, xy coordinate point, let's draw this. Also draw our angles. Remember, this is 0 degrees. This is 90 degrees, 180 degrees, and 270 degrees. Then if we go all the way around, it's also 360 degrees in a positive direction. Let's just draw an angle. Let's draw a point right here. It could be anywhere. Once again, just make it right here, x and y. Okay. Now, the distance from that point to the origin is given by r. Okay, that's the distance. Then what happens is I can essentially make a little angle here, okay, where this is x and this is y. And what happens then is then I can base my, since I have a triangle here, it's like a right triangle, then I can actually define trig functions in terms of x, y, and r for any point in space, in any quadrant. Okay. I'll also review a few more things while we're here. So, of course, this is quadrant 1. Okay. Now, let's take a look. So sine is defined as y over r. Okay. So think about this kind of like being my angle right here. This is angle theta. Okay. Then it's the same, just like here, it's the same as what we saw before. So opposite over hypotenuse, this is y over r. Cosine is going to be x over r, adjacent over hypotenuse, or x over r. Tangent is going to be opposite over adjacent, or y over x. Okay. Now, one thing that's useful to know here then is that this quadrant, sine of theta is positive, cosine of theta is positive, and tangent of theta is positive. Okay, everything is positive in the first quadrant. Not surprising. Now, let's go to quadrant 2. So if you have an angle in quadrant 2, then over here, maybe on this side of the x-axis, the y-axis, then sine, since sine is given in terms of y, remember r is a length, r is always positive. So sine is y over r is positive, but cosine of theta is negative because x is negative in quadrant 2. And it's x over r, and r is always positive. Cosine is negative. And so if you do tangent y over x, you have opposite signs, so tangent is negative. And also I should mention that the inverse functions, if you notice, not the inverse, the reciprocal functions have the same signs as their, for example, the reciprocals have the same signs as each other. So taking the reciprocal of a number does not change its sign. So cosecant has the same sign as sine, secant has the same sign as cosine, cotangent has the same sign as tangent. Okay. Now, same thing in quadrant 3 down here. Okay. Now, if you know both x and y are both negative in quadrant 3, that means that sine as y over r is negative. Cosine as x over r is negative. And then for tangent, you'd have a negative divided by negative, which is positive. So tangent is y over x. That would be positive in quadrant 3. And finally, in quadrant 4, okay, so we're below the x-axis, so y is negative, therefore sine is negative. We're on the right side of the y-axis, so x is positive, so then cosine is positive. And then, since see that x and y have opposite signs in quadrant 4, then tangent is negative. Okay, and once again, remember that the reciprocals have the same signs as their accompanying functions. All right, and once again, remember that r is this length, so r is always positive. So from this, using x and y and r, we can always find the values of our trig functions for any point like that. Okay, let's take a look at a couple examples of that and see how that works. So number 1, examples. Okay, actually, let me double check, make sure I have plenty of space. Yeah, make sure I have enough essentially virtual paper for this. All right, so number 1, I want to find the trig functions for, let's say I have a point, which is, make this -12, -5. Okay, so first what we want to do, let's draw that. So -12, -5. First, I'm going to figure out which quadrant you're in. And of course, in this case, you're in quadrant 3 since they're both negative. Okay, so -12 is -5. Let's say it's about right here. Okay, so let's make a little triangle. Try and draw that a bit better. Okay, here's our point. So this side is -12. This side is -5. This is our R. Okay, well, actually, this erase, yeah, that's where he's going to erase that whole thing. So let me draw the x-axis a bit smaller. So first, let's find R. Okay, we can do that with the Pythagorean theorem. Since we have a right triangle here, then we're going to have r squared is equal to -12 squared plus -5 squared. And of course, then r is a square root of that. Once again, since r is positive, it's a length. Generally, when we take the square root of both sides, you get a positive or a negative. But since r is positive, it's a length. Let's use the positive version. So -12 squared plus -5 squared. Let's go to Desmos and do that. That's the easiest way to do it, or your graphing calculator. We can also do it, especially with a graphing calculator, you can do it the same way. So to get a square root, just type, one way is just SQRT. Then let's just make sure you use parentheses because we're squaring the negative as well. So -12 squared, okay, plus -5 squared. That comes out to be a nice number, 13. Okay. Works out really well. So 13. So r is equal to 13. Now that I know that, I can find all the trig functions. Okay. Also, I should say one more thing. My angle theta looks like this. Theta goes from the positive x-axis to this line where r is. Also, any point along this line would also have the same value as the trig functions as well. And also, actually, any coterminal angle that ends the same place will also. So, sine of theta, which is y over r, is going to be negative 5 over 13. Okay, I'll just do so cosine of theta, which is x over r, is going to be negative 12 over 13. And then tangent, which is y over x, is going to be negative 5 over negative 12. And of course, is going to be positive 5/12. Then the reciprocals, you either use the definitions, just use the fact they're reciprocals. Cosecant is a reciprocal of this, okay? And that's going to be negative 13 over 5, or also the same as r over y. Secant is a reciprocal of cosine, and that's going to be negative 13 over 12. And then cotangent is a reciprocal of this, and that's just going to be 12/5. So those are the values of our trig functions. And that's pretty easy to do. All right, so first off, find your, for a point you're given, find which quadrant it's in, draw a picture, draw a little triangle like this, okay? Find the missing side, and then find your r, then find your trig functions. All right, let's do another example. So number 2, this time, I'll just say find the trig functions, technically the values of the trig functions. For the point, how about we do 3 and 8? Okay, well, now let's make it, how about negative 3 and 8? Okay, so negative 3 and 8. So first off, figure out which quadrant you're in once again. Do that again. So x is negative, y is positive, actually in quadrant 2. And so 3 and 8. Roughly is about right here, negative 3 and 8. So it's going to make this length here. This is going to be our r. This is our angle theta, then it comes from the positive x-axis to there. All right, and make a little triangle, right triangle. And of course, this is negative 3, and this is positive 8. Okay, so the same thing. Once again, we want to find our r and do it the same way. So r, I'll just go and do the square root this time, the square root of negative 3 squared plus 8 squared. Okay, once again, let's use decimals for that. This one probably will not come out as nicely, but we'll work on that. So do the square root, type SQRT, then it was negative 3. Make sure you use parentheses to square the negative as well. Negative 3 squared plus 8 squared. Okay. Well, we could use a decimal, but actually want to do this in exact form. So actually back up. So I want to make this exact. So this is going to be square root negative 3 squared is negative 3 squared is 9 plus 64, 8 squared. And so that's going to be the square root of 73, which I don't believe can be simplified. So that's it. Okay. Now this actual little practice of rationalization. All right. So the same thing. The sine of theta, okay, is y over r. So y is 8 over r, which is the square root of 73. Now to rationalize, non-rationalizing, I want to get rid of the radical, in this case, the square root of the denominators. The best way to do it with the square root is just multiply the top and bottom. First, you want to simplify your square root first if you can. In this case, we can't. Multiply the top and bottom by the square root. Top and bottom by the square root of 73, because this is square root of 73 over itself is 1. We're not changing what the number means. So this is going to be 8 over the square root of 73 over, and square root of 73 times itself would just be square root of 73 squared, which is just 73. Okay, if you have to rationalize, that's how to do it. Cosine, same thing. And so it's going to be -3 over the square root of 73. So do the same thing. Multiply the top and bottom by the square root of 73. This will be -3 times the square root of 73 over 73. Then tangent of theta. In this case, I might not have to rationalize this one. Let's see. And this is y over x. So that's going to be y 8 over negative square root of 3. I'm just going to leave the negative out there, bring that front. That's fine. Okay. Now, if we do the reciprocals, the cosecant of theta, reciprocal of this, and actually that one, we can just go from this version here. So it's going to be r over y, the square root of 73 over 8. Okay. Secant, reciprocal of cosine or secant itself is r over x. That's going to be the square root of 73 over -3. And then cotangent, the reciprocal of tangent, or x over y is going to be -3 over 8. And those are the values of the trig functions. Okay. Now, let's look at one more idea, reference angles, which we've already done a bit, though we didn't call it that. Let's talk about reference angles. All right, let's go down the next page. Okay, so the idea of a reference angle and depends on which quadrant you're in. So this is a reference angle of some angle theta is an acute angle that the angle theta makes with the x-axis. Okay, so the way we're going to look at that is, let's say, you have an angle in quadrant 1. Okay, the idea, if this is my angle theta, okay, so what you're doing is you're making a right triangle with the x-axis. Okay, in this case, theta is equal to its own reference angle. So quadrant 1 is easy, we don't really care that much about it. Okay, now quadrant 2, okay, here my angle looks like this. Let's see, you know, in fact, let me just actually change this. It'd be better, instead of trying to do all this on one, let me do this in a couple different, 3 or 4 different ways. Okay, so in quadrant 1, let's get the easy case. Okay, we have an angle like this. This is theta. Theta is equal to its own reference angle. Okay, that's a simple case. Quadrant 2. So in quadrant 2, then we have some angle over here. Okay, so that's our angle. What we're going to do then is kind of what we already see. We're going to make a right triangle, an angle with respect to the x-axis. And this is what's called our reference angle. Okay, it's theta prime. Okay, it's an angle with respect to wherever your angle is, in which quadrant that angle with respect to the x-axis. Okay, and quadrant 3, then your theta 1, your reference angle, theta prime, is equal to 180 minus your angle theta. Okay, that's how you get that value. And from this, then potentially you can use right triangle trigonometry the way you did in the last couple of examples, basically to find your values of your trig functions. Okay. And in quadrant 3, the reference angle, okay, so if some angle down here, looks like this. This is our theta. So once again, we make a reference angle with respect to the x-axis, theta 1, we make a little right triangle, and this angle, this quadrant, then the reference angle, how we get that is going to be your angle theta minus 180. Okay, difference between theta and the x-axis. And then finally, in quadrant 4, okay, let's say we have an angle that ends here. So here's our angle theta. And this reference angle is this angle right here where the x-axis wants to make a little right triangle. Okay. And in this quadrant, then, how to get the reference angle is you're going to do your theta prime, your reference angle is going to be 360 minus theta. Okay. Your angle here is going to be between 270 and 360 degrees. So 360 minus that gives you reference angle. And then you can use potentially your right triangle trigonometry to find the trig values of that angle. Okay. So now, why do we do that? Well, let's take a look at a few examples then. In fact, let's just go down here to the next page. Let's do some examples. So let's find trig functions of, actually, before we do that, we should have a little space here. Let's actually use this space. Let's review our what's called our special triangles, because they're often useful in this. Special triangles, there are two. So there's the 45, 45, 90. Okay. Let's say this angle here is 45 degrees. This here is also 45 degrees. So if we think about that, we have sides 1, 1, and the square root of 2. Okay. The way you get that, if these lengths are both 1, use the Pythagorean theorem to find this side is the square root of 2. This is the 45, 45, 90 triangle. The other one is the 30, 60, 90 triangle. Okay, so it looks like this. So this angle is 60 degrees. This one is 30 degrees. Okay. Now the side has a length of, the hypotenuse has length 2. This side is length 1. And then also if you use the Pythagorean theorem here, knowing hypotenuse is 2 and this side is 1, you get this as the square root of 3. This is the 30, 60, 90 triangle. And these are often used. Okay. So let's find the trig functions of 135 degrees. So how do we do that? What does that mean? Well, we'll take a look at this. First off, 135 degrees, which quadrant is that in? Well, let's draw a picture. So here's 0 degrees, 90 degrees, 180 degrees, and 270 degrees. And of course, back to 360 here. 135 is actually in quadrant 2. Okay. So what we're going to have then is going to have a reference angle right here, the theta prime. And that theta prime is going to be 180, as we saw in here above, here in quadrant 2. To find your reference angle, it's 180 minus your angle, like this picture right here. 180 minus 135, and it turns out that's 45 degrees. So this angle is 45 degrees. Okay, make that reference angle. Make a right triangle. That means this angle here is also 45 degrees. So all the angles have to add up to 280. Okay. Now, since we know this is a 45-degree angle we're making with the x-axis, that's a reference angle, then we can use our special triangle here and just remember the sides. Okay, so this side is going to be 1, 1. This r is going to be the square root of 2. But since we're in quadrant 2, remember which one is positive, which one is negative. Y is positive, x is negative. This needs to become negative 1. Okay, so once we do that, then we can find our trig functions. So sine of, actually not sine of theta, in this case, you know the angle, sine of 135 degrees, okay, is going to be, using the same definitions, okay, you can think of this as either x, y, and r, or even think about the sides, you know, adjacent hypotenuse from the reference angle, okay, so sine is going to be y over r, or in terms of the opposite adjacent hypotenuse, opposite over hypotenuse, that's going to be 1 over the square root of 2. If you rationalize that, multiply the top and bottom by the square root of 2. And so you get the square root of 2 over 2. Cosine of 135 degrees, okay, is going to be x over r, or adjacent over hypotenuse. So that's going to be negative 1 over the square root of 2. That's going to multiply the top and bottom by the square root of 2. And that's going to be negative square root of 2 over 2. And then tangent of 135 degrees. Okay, so what's that going to be? Well, that's going to be using the same triangle. You can think of it as y over x, or from a reference angle, opposite over adjacent, this is going to be 1 over negative 1. It's going to be 1. Okay, then the reciprocal, so cosecant of 135 degrees, is going to be just, in this case, the square root of 2 over 1, which is the square root of 2. Secant of or I keep writing theta, of 135 degrees is reciprocal of cosine. So negative square root of 2 over 1, which is the negative square root of 2. Then, of course, cotangent, 135 degrees, is the reciprocal of tangent. And so that is going to be negative 1 over 1, which is just negative 1. I'm sorry, this should have been negative 1. I apologize. They both should be negative 1. Okay? So let's do one more example of the reference angles. Actually, I may need a little more space. Just a second. Let me just to make sure I have plenty of room so I don't have to do anything. Good. Okay. Let's do another one. In fact, let's probably just go down and do on 2. So this next page. So let's do find trig functions or trig values of, and let's see, in this case, let me pick, how about 310 degrees? Okay, so 310 degrees. No. No, let's make that 300 degrees. Yeah, that should work. Okay, so let's draw a picture, figure out where we are. The first thing, 0 degrees, 90 degrees, 180 degrees, and 270 degrees. Okay, remember, go all the way around, it's 360 degrees. So clearly, we're in quadrant 4. Okay, between 270 and 360. So 300 is about right here. Okay, so our angle goes all the way around here. That's 300 degrees. So once again, I want to make a reference angle. This reference angle right here, theta prime. Okay, and once again, in this quadrant, the way we do this is go back to our rules. So to do that in quadrant 4, what we're going to do is going to be 360 minus our angle. So we find our reference angle. Okay, and so our theta prime is going to be 360 minus 300, and of course, clearly that's going to be 60 degrees. So this is equal to 60 degrees. This then is equal to 30 degrees. So to make 180 degrees all around, we use our special triangles once again. Okay, so our sides, the hypotenuse is 2, our r is 2, and the side opposite of 60 degrees is square root of 3. The sides opposite of 30 degrees is 1. So let's fill all those in, and then we'll figure out the sines. So this side is 2, that's the hypotenuse. The side opposite square root of 60 degrees is the square root of 3. And the side opposite 30 degrees is 1. And in quadrant 4, y is positive, or sorry, x is positive and y is negative. Okay, then once we have that, we can find all our trig functions. And this time, I'm actually going to start with the what I call the reciprocal ones, because those are just as valid trig functions as the other 3, just for something to do something different. So cosecant of 300 degrees is equal to r over y. And so that's going to be r, which is 2, over y, which is negative square root of 3. Okay. And then to rationalize that, multiply the top and bottom by the square root of 3. And so that's going to be negative 2 square root of 3 over 3. Okay. The secant of 300 degrees. I'm having trouble writing with a writing pad today. I guess I haven't used it as much in the last few days. Okay. Is r over x. So that's going to be 2 over x, 2 over 1. And that's nice, just becomes 2. And then cotangent of 300 degrees is x over y. And so that's going to be 1 over negative square root of 3. So to rationalize that, multiply the top and bottom by square root of 3. And that's going to be negative square root of 3 over 3. Okay. Then their reciprocals, we can either use the definitions or the reciprocal. In fact, the reciprocals of these, so reciprocal cosecant is sine. And so then the sine of 300 degrees is going to be actually just negative square root of 3 over 2, starting here. The cosine of 300 degrees is the reciprocal of 1/2, or 2 over 1, which is 1/2. And then finally, the reciprocal of cotangent is tangent of 300 degrees. And that's going to be negative square root of 3 over 1, or just negative square root of 3. Okay, And that's one way is how can you use, especially use reference angles if they happen to be nicely, have worked out nicely like that. Now, often things like that won't work out that nicely. Okay. So what if you have something like this? I want to find the values of, or find the trig functions of a different angle. Let's say find the trig functions. Try that again. Find the trig functions of, how about we do, let's see, how about 231 degrees? Okay, 231 degrees. So once again, same thing. Where are we? Well, this is 0, this is 90 degrees, 180 degrees, and 270. So clearly we're in quadrant 3. The 231 is about right, maybe about right here. Okay. Now, we can certainly do a reference angle, and we'll do that real quickly just for completeness. Just bear with me here. I'm having trouble writing today. Okay. So we do a reference angle, make a little triangle again. So this angle theta 1. Okay. So in this, it's going to be theta 1 is going to be the angle minus 180. So 231 degrees minus 180 degrees. And that's going to turn out to be 51 degrees, which is true, but that's not a special triangle, special triangle. What we have to do here then is simply just use the calculator. Okay. And then also make sure you're in degree mode, whatever calculator you're in. Okay, that's important. And let's just not do all of these. We'll do a few of them. So let's do sine of 231. Okay. And also one thing we can check, sure we get the values we expect. Okay. Sine, of course, we know sine in quadrant 3, sine is y over r, so it should be negative. Make sure that's true. And so let's do here. And also let's make sure we're in degree mode. Let me go back and check. So a little wrench. No, we're in radians. Make sure we're in degree mode. That's really important. So then sine of 231, yeah, it is negative. That doesn't guarantee it's right necessarily, though this is, but at least it tells you your sign is correct. Let's do 2 decimal places, so negative 0.78. Okay, and let's do one more. Let's do cosine. Let's do cosecant. You're going to do cosecant on these. So cosecant, a couple ways you can do this. Okay, if you have a cosecant, this one you can actually do this on Desmos. So cosecant of 231 is also will also be negative since reciprocal negative 1 point. Let's call it negative 1.29. Okay. Or the other way to get cosecant is going to be 1 over the sine of 231 degrees is equal to yeah. So that'd be 1 over the sine of 231. So we can do that to make sure this is correct. Okay. And just do now 1 divided by sine of 231. Right. And to get exactly the same value as we should. You can find all the trig functions. Sometimes you have to do that because sometimes, and often in real life, angles you're going to get are probably not going to be ones where you have these nice reference angles with a special triangle. So often we have to do this by hand with a calculator. So it's good to make sure you can do that. All right. So what we've learned today is we've learned about complementary and supplementary angles. Complementary angles add to 90. Supplementary angles add to 180. Also learned about coterminal angles. Angles add in the same place. And for example, the examples we just did, we're finding these trig functions of here. So any trig function, so for example, angle 231 degrees, if you add 360 or subtract 360 or any multiple of that to this, you'd have a coterminal angle, and then we'll also have the same value of those same trig functions. Okay, that's true of any of the things we've done today. We also found how to find the trig These are trig functions for any angle. If we have know a point in space, we can find that, and also found how to use reference angles. Thank you. Have a good day.